This is a video supplement to the comments that Dash Core Group has submitted in response to FinCEN's NPRM dated December 23rd, 2020. It's entitled Requirements for Certain Transactions Involving Convertible Virtual Currency or Digital Assets. Dash Core Group provided an initial response on the initial due date in January of 2021 and has submitted an additional set of comments on the extension in March of 2021. So let's dive into the content. First, an introduction. Dash Core Group feels that Dash has been wrongfully named as an anonymity-enhanced cryptocurrency according to the information we've been provided by the U.S. government on what it considers a anonymity-enhanced cryptocurrency to be. Department of Justice's cryptocurrency enforcement framework in October of 2020 and FinCEN's notice of proposed rulemaking in December of 2020 describe anonymity-enhanced cryptocurrencies as a money laundering risk and indicated that they believed that the use of anonymity-enhanced cryptocurrencies is indicative or correlated with a higher risk of general illicit use. We'll examine that claim. The stated reason for categorizing AECs is that they believe that they inhibit investigators' ability to identify transaction activity involving blockchain data and to attribute the activity to illicit actors. And while the government's efforts to prosecute illicit actors is certainly a laudable effort, the current definition of AECs is vague, inadequate, and in the case of Dash has wrongfully categorized an asset as an AEC. But let's start with the assertion that anonymity-enhanced cryptocurrencies that the Department of Justice and FinCEN have identified as such pose an elevated risk of money laundering and illicit activity. The data simply does not support that assertion. RAND Europe conducted an analysis of dark web cryptocurrency address usage last year, and they identified cryptocurrency wallets in their dark web data set, and the overwhelming majority of those addresses were associated with Bitcoin. In fact, 91% with that single asset. When you count other transparent networks like Bitcoin, Litecoin, and Ethereum that were at the top of the list, that total reaches nearly 94%. Though this is obviously not a complete list. The anonymity-enhanced cryptocurrencies on this list, which would include Zcash, Dash, and Monero, constituted 0.3% of illicit addresses in their data set. Dash in particular was the least used of the three. It only comprises 0.05% of total address usage in their data set. This usage is so low that even if you account for Bitcoin's relative market cap in comparison to Dash and made an adjustment, Bitcoin's illicit use is more than 3 times higher than that of Dash. And so this assertion that these assets, and these specifically named assets, carry a higher risk of illicit activity is actually contradicted by the available data. And I think you'll see why that is the case in a few moments. Bitcoin has a great deal of privacy built in to its protocol and tool set that's available on the network. It also enjoys great network effects in terms of accessibility and common usage. And so those are things that I think contribute to Bitcoin's disproportionate use on the dark web. So let's look at the definitions being put forward of an anonymity-enhanced cryptocurrency. FinCEN provided guidance back in 2019, May of 2019, in their application of regulations to business models involving convertible virtual currencies. And in October 2020, the U.S. Department of Justice published a definition in their cryptocurrency enforcement framework. Under FinCEN's guidance, they claim that anonymity-enhanced transactions are transactions that are either denominated in regular cryptocurrency but structured to conceal information that would otherwise generally be available through the native distributed public ledger, or, and this is where they define privacy coins are denominated in cryptocurrency specifically engineered to prevent their tracing through distributed public ledgers. Now, the problem with this definition of a privacy coin is that, first of all, it depends on the engineer's intent for a given technology. Now, why is that an issue? Many technologies have more benefits than simply privacy. Privacy may be a primary goal, it may be a secondary goal, or it may be a side benefit of, or a consequence of, but not the main reason why an engineer incorporated a certain engineering decision. And so this definition depends on what the reasons are why an engineer chose to implement something the way that they did. That in and of itself is problematic for obvious reasons. And in fact, Bitcoin itself was engineered or designed to provide privacy to its users. It's called out in the Bitcoin white paper that Satoshi Nakamoto wrote. By that definition, Bitcoin would be considered an anonymity-enhanced cryptocurrency, and I think we mostly agree that it is not. Now, the second part of this is that it prevents tracing through distributed public ledgers. Dash has implemented CoinJoin on its network, and CoinJoin doesn't depend on obscuring any information that is generally available through Bitcoin's native distributed public ledger. CoinJoin requires no changes to the transaction protocol itself. CoinJoin operates by complicating transactions, but it doesn't obscure any information or prevent chain analytics companies from analyzing, or the government from analyzing transactions and attempting to attribute the activity to illicit actors. And so Dash does not meet this definition, yet was specifically named as an anonymity-enhanced cryptocurrency. The Department of Justice definition is frankly unusable by the industry. It says that other cryptocurrencies use non-public or private blockchains that make it more difficult to trace or to attribute transactions. These are often referred to as anonymity-enhanced cryptocurrencies or privacy coins. And then it gives examples. Examples of AECs include Monero, Zcash, and Dash. Now, Dash operates on a public ledger. All transaction inputs, input addresses, amounts, outputs, output addresses, and amounts are all listed for every single transaction all the way back to the Genesis block. That includes CoinJoin transactions. And so in providing these examples, it directly contradicts its own definition. Nearly all cryptocurrencies are recorded on public ledgers. It's a question of what information is recorded on those public ledgers, how accessible it is, to whom, under what conditions. And so all of the examples here have chain analytics tools available to them through CipherTrace or Chainalysis. And so this definition is simply woefully inadequate and actually contradicts itself within the definition. So let's talk about Dash's specific privacy enhancing technology. CoinJoin is a consumer grade privacy technique, and it's aimed at providing a user with a greater level of security. Dash's PrivateSend is simply a branded implementation of CoinJoin, and its implementation is non-custodial in nature. Like all CoinJoins, Dash's CoinJoins involve the combination of inputs to a transaction from multiple users. CoinJoins, by definition, are simply multiple users joining together in a common transaction. And they can take many different forms. CoinJoin does not involve the transmission of user funds to any intermediary. All funds remain in control of the user, at least within Dash's implementation. There are some exceptions, but on the Dash network, this is true. Coins are simply being moved in these transactions from one address within the user's wallet to another address within the user's wallet. And so there's never a transmission of funds using CoinJoin. It requires no modification to the Bitcoin protocol. These transactions continue to include all inputs, all outputs, addresses, and amounts. CoinJoin is user initiated. It's optional. And in fact, in Dash's network, it's only used about 0.38% of the time in 2020. So it is scarcely used. When it is used, it's easily detected because of the standardized nature. You'll see an example of one in this presentation. They all look very similar to one another, and it's easy to identify when a CoinJoin is being used. What we describe the privacy level here is good enough for user safety purposes. If user A sends a transaction to user B, and user B sees the change going back to user A is a large balance, that could put user A at risk of physical harm or of a digital attack. And so users should expect a basic level of privacy, certainly over their balances and their transaction history for casual users that they interact with, or casual interactions that they have with other participants of the network. What CoinJoin does not do is impede investigations. Chain analysis tools exist specifically to analyze CoinJoin transactions so that exchanges can know when they're used, appropriately risk score them, and even attempt to attribute the transactions to a source or a subset of potential sources. CoinJoins are dependent on the behavior of other users within the network. And so my own level of privacy is affected by my own behavior and by the behavior of others. And that makes it kind of a privacy technique that is good enough to thwart most everyday threats, but probably not good enough to thwart the US government or a sophisticated actor like an exchange that has access to chain analytics data. it's worth understanding how a CoinJoin on Dash's network works. A PrivateSend transaction consists of 3 stages. In the first stage, a user simply takes an input in their wallet, in this case 5.32 Dash, and breaks it down into its components or denominations. So in this case, 5 ones, 3 0.1s, and 2 0.01s. Once the user's funds are denominated, they would be permitted to enter into CoinJoin transactions with other users. So in stage 2, transactions are constructed that meet the end user wallet requests. The end user wallets sign the transaction if they agree with it and feel that it meets the constraints of the CoinJoin rule set, and send the funds from one address in their wallet to another address in their wallet in the same transactions that other users are doing the same thing. And then in stage 3, at some point in the future, they can spend their Dash in a much safer manner. So in stage 3, this user is spending 2.21 of their 5.32 Dash. And in order to send that amount, the wallet simply constructs the transaction by using 2 1 Dash inputs, 2 0.1 Dash inputs, and 1 0.01 Dash inputs. Of note, the receiver address is always normal and transparent on the blockchain and is no different than any other transaction. So the 2.21 Dash, those 5 inputs, would be sent to a specific address that the user specifies. And this is what the resulting transactions look like on the blockchain in that second stage, in which these transactions are actually utilizing CoinJoin. So this particular example is actually on the Bitcoin network. You'll see here that there are 20 inputs and 20 outputs, each of a common amount. And so you've got the inputs numbered 0 through 19 and the outputs numbered 0 through 19. Each of the addresses could belong to one of 3 participants on both the input and the output side. And so it introduces a great deal of uncertainty as you are analyzing this blockchain and determining what the origin source of funds might have been. You'd have to look further back in the transaction history in order to narrow down the potential sources of funds. Interestingly, depending on the behavior of the other participants to this CoinJoin, my level of privacy may be affected. So if at some point in the future someone spends some of these outputs in a manner that links them to the original address, for example, by mixing together some of these denominated outputs with some of their funds that never went through this process, a great deal of anonymity or privacy throughout this entire chain of events would be affected. And so it really is dependent on what the behavior of other people are doing. It also depends on the number of outputs that the end user eventually uses in a transaction. The more outputs they use, the narrower the range of potential branches on this tree that those outputs could be attributed back to. And if the user uses too many, you can potentially narrow it down with almost certainty, or even certainty under certain circumstances. And a user's level of privacy could actually change over time. At the time that I conduct a transaction, the level of privacy could be quite high. And at a later point in time, if some of the people that I participated in these CoinJoin transactions with actually reveal information about the transaction histories, my level of privacy could actually drop over time, long after the transaction is complete. So there are many limitations to a CoinJoin. Now this, as I mentioned, is on the Bitcoin network. What you'll notice is that we actually conducted that transaction on the Bitcoin network to illustrate that there are no restrictions from being able to do these types of transactions on Bitcoin's blockchain. We did a Dash style of CoinJoin on Bitcoin's network, and here is the Dash version. Now, as I flip back and forth between these two slides, you can see that the transactions are functionally identical. About the only thing that's different is the address format, and that's a trivial difference. The amounts are all the same, the number of inputs, the number of outputs are all the same. You can conduct functionally identical transactions on Bitcoin's network. And in fact, you don't even need software to do it that is specifically designed for this. It certainly makes it easier, but it's not a requirement. So in order to conduct coin joins, one only needs to be able to coordinate and find other users that want to or desire to enter into a transaction in common. And secondly, you need a mechanism to share the details of the transaction that you're constructing. And that can take place through any medium in which information can be shared. It could be done through a chat room. It could be done through an online spreadsheet. It could be done through the mail or over a telephone call. Any means by which users could share the details of a transaction and construct a common transaction with one another would suffice. Now, there are many non-custodial coin joins, and virtually any decently sized transparent network has an implementation of CoinJoin or other technologies that are similar. So as Dash has a desktop wallet that does this, Litecoin has a Mustard wallet, Bitcoin Cash has Cash Shuffle and Cash Fusion, Bitcoin has Samurai, Wasabi. So there's many examples of networks that have implemented CoinJoin. It's probably the most popular privacy feature, as it is readily available for nearly any transparent blockchain. Generally speaking, CoinJoin transactions are simple to identify and to trace. That means that they act more as security, as I mentioned, than absolute privacy. The exact same techniques are used to analyze CoinJoin transactions regardless of which network they're on. Those same analytics techniques are used on Bitcoin, Litecoin, Bitcoin Cash, and Dash. And so any transparent blockchain utilizing CoinJoin would be subject to the same blockchain analytics techniques. What's really interesting is when you put Dash side by side, feature by feature, against other coins that are not considered to be anonymity enhanced. Dash was the first to market with a CoinJoin implementation that was non-custodial in nature. And that since has happened on other networks as well. And in fact, 2015 through 2017 really saw an explosion in a new set of privacy enhancing techniques that are deployed in concert with or alongside CoinJoin. Here's some examples. Chaumian CoinJoin. This is a type of CoinJoin that is enhanced so that even the coordinating server cannot see details of the transaction, including the addresses that belong to each of the participants. That information is normally shared in the coordination of a CoinJoin, but in the case of Chaumian CoinJoin, the coordinating server gets the exact same information that any other observer of the blockchain would have access to, and that is the on-chain data. Off-chain transactions, Lightning Network and Liquid, these are transactions that aren't actually recorded on the Bitcoin blockchain. And in fact, nodes operating the Lightning Network do not have access to the origin or destination of funds traversing the network that they are routing. Nor is there any repository in which you can see in a network-wide picture of the number of transactions, type of transactions, size of transactions that are traversing the network. And so it is very private form of transactions when you conduct those off-chain. Excuse me. Then we have third-party tumbling services. These are very familiar to a lot of people, but basically you send your Bitcoin to a tumbler and they will send you fresh, different coins back. Mimblewimble is a side chain that is launching on Litecoin in Q2 of this year. And basically Mimblewimble is a lot like an individual block, acts like one giant transaction, one giant CoinJoin, if you will, in which a single input and single output is effectively created. And that shields a great deal of information about the transaction activity using Mimblewimble. Batch spending is when multiple users will conduct a transaction in which they're both spending. And by combining their transactions, none of the information is technically obscured. It's all still there. But it does complicate the possible scenario of who is paying whom compared with two separate transactions where that information may be much more straightforward to derive. Boltzmann clustering resistance. This is not technically a CoinJoin, but it creates a transaction that looks like one. Now, how could that be useful? In one example, if I were to send a transaction from myself to another party, and the other party analyzed the transaction and identified some issue with it, whether something in the transaction history, they didn't like who I donated to in terms of politics, or any information that I wouldn't want them to know, it creates a situation of plausible deniability. Because it looks like a CoinJoin transaction, I can falsely claim that it was one, and therefore that the input addresses associated with the activity was not mine. BIP47 payment codes. These are also known as stealth addresses. BIP47 payment codes essentially keep a user's address private. They don't have to transmit the address to the sender, and therefore can avoid sharing that information through media that could be subject to man-on-the-middle attacks, or divulge information about the end user. And so the addresses simply aren't seen until they're actually used. Transaction hopping. This is a technique that is meant to thwart chain analytics software or exchange software that might have a rule in it that says that the analysis will only go back 4 or 5 transactions in history to analyze the type of activity there. And by simply sending the money around between, bouncing the money around between a bunch of addresses, the sender controls, and then eventually to the destination address, it can actually trick the software into not searching further back into the blockchain than those transaction hops that were artificially created. And then, of course, you have shielding addresses and amounts, which may obfuscate data in a way that makes attributing addresses extremely difficult or non-applicable. In addition, Bitcoin is in the process of deploying Taproot, which includes quite a number of privacy-enhancing features, including a technology called CoinSwap, which will effectively allow for CoinJoin transactions or mixing transactions in which they aren't readily identifiable on the blockchain as such. There's a number of other advancements with Taproot, Schnorr signatures, and other types of transactions that reveal less information about regular transaction types. And so in summary, it's really difficult to compare these networks side by side and determine that Dash is somehow a higher threat of money laundering when in fact it is hardly used for illicit purposes in the first place, according to all the data that we're aware. And secondly, that the side-by-side comparison of the feature set just doesn't make sense why Dash would be considered an anonymity-enhanced cryptocurrency, while Bitcoin is not. There isn't a single Dash privacy feature that is not already implemented in Bitcoin, and there are numerous privacy features that have been implemented in Bitcoin that have not been implemented in Dash. There is absolutely no overlap and no instances that Dash has a privacy feature that Bitcoin lacks. And so let's look at the summary here. Firstly, the current definitions of anonymity-enhanced cryptocurrencies are vague, ill-defined, and arbitrary enough to be a catch-all for virtually any cryptocurrency deemed inappropriate by the US government. The definition doesn't take into account the multidimensional nature of privacy. So it attempts to label currencies in a binary fashion. And it doesn't take into account not only that this isn't binary, but that it's multidimensional in the sense that what type of privacy is provided, over what information, for the senders, for the receivers, under what conditions, what dependencies is that privacy based on? Are there view keys in which information can be selectively shared? This is a very complex set of features that are difficult to boil down into a simple definition. But regardless of which definition you use, there is no definition you could come up with that Bitcoin is not an anonymity-enhanced cryptocurrency and Dash is. That simply is not the case. Dash is hosted on a public and transparent blockchain with a relatively simplistic implementation of CoinJoin that is readily identifiable even by the naked eye on the blockchain, where any entity is able to trace all inputs, outputs, addresses, and transaction amounts all the way back to the Genesis block. We have a hard time accepting that that makes Dash an anonymity-enhanced cryptocurrency. Dash is minimally used on the darknet. It was used less than Litecoin, Ethereum, Bitcoin Cash, Zcash, Monero, and Dogecoin. And so, again, there's just no evidence that Dash is some illicit money laundering risk. CoinJoin itself is an implementation of non-custodial CoinJoin. Virtually all networks feature a wallet with this functionality. It's analyzable in the same method and that is already used with the other networks. And there are a number of enhancements that aren't available on the Dash network. And so we've concluded that Dash should not be considered an anonymity-enhanced cryptocurrency. There's no basis for that label. And in fact, Dash's privacy risk profile is much lower than Bitcoin's. And it's not just us saying this. There are experts within the industry Perkins Coie issued a white paper last year. Chainalysis, when they added support for Dash, stated Dash's privacy functionality is no greater than Bitcoin's, making the label of privacy coin a misnomer for Dash. They are saying that it is not an applicable label. And these are the people that the US government trusts to advise them and provide analytic services. And so the experts absolutely agree that Dash should not be considered an anonymity-enhanced coin. At this point in the presentation, we would like to present some more technical information. This may not be appropriate for all audiences, but for the analysts on the teams at FinCEN and Department of Justice, we would encourage you to get this information to those teams because what we're going to go through is examples on Bitcoin's network of some of the more advanced CoinJoin techniques that wallets in Bitcoin have implemented and Dash has not. And so in this first example, this is a generic CoinJoin. This is something that's very similar to what Dash's PrivateSend function provides. And what you see here is an example of CoinJoin on Bitcoin's network. This particular implementation is in the Samurai wallet, and the brand of it is called Whirlpool. And what you'll see in this video on the left is the user interface in which the user selects that they want to use Whirlpool. They select their inputs. They select the pool that they want to use in order to conduct their coin joins, and then they initiate what's called a cycle. And basically the transaction first, or the wallet first breaks down the input in the upper left of the white boxes here into a set of denominated outputs that I've highlighted in orange on the right. And those outputs are later used in CoinJoin transactions with other participants. You can see 3 examples here in which one of the addresses from the left shows up in one of the transactions down below. And what you'll notice is that they are conducting these transactions with other participants using addresses that are not controlled by the sender. And so what this is doing is simply moving the funds from one address in the wallet to another set of addresses in the wallet. What a third-party observer cannot determine is which of these addresses on the right belong to this particular individual that denominated their coins in that first transaction. And that's what creates some uncertainty over funds being spent at a later point in time. They may be attributable back to this particular address, but chances are they can be attributable back to others as well. It is apparent that a CoinJoin transaction is taking place. You can see the denominated amounts, and the outputs are all identical. And so it is easy to determine that a CoinJoin has taken place here using blockchain analytics or even the naked eye. So let's switch to some of the more advanced forms of CoinJoin that are not available on Dash. This is a Bitcoin spend and CoinJoin example. This again is the Samurai wallet, and this transaction type is branded as Stonewall X2. It is a CoinJoin transaction. There are 2 users involved here. The yellow is paying the blue in this particular example. And I'll just start the video so you can see the user interface as this transaction takes place. But basically, the yellow user does end up sending about 0.00086 Bitcoin to the Teal user. But what's interesting about this transaction is that the Teal user also provides an input. And so the two are coordinating this with each other through these QR codes. That's how they're sharing the information in these particular wallets. And the sender and the receiver then receive a set of outputs. Now, this particular transaction is made to look like a CoinJoin denominating transaction in which a user, a single user, is breaking out certain amounts for a CoinJoin. Third-party observers may conclude that this is a preparation for CoinJoin or another type of transaction in which a CoinJoin is spent. And so it may not appear to be mixing at all in this particular case. Now, if you notice, the yellow line started with 0.015 Bitcoin and ended up with 0.01385. And the other user actually increased the amount of Bitcoin that they had in total. And so this is a send. It just doesn't appear as a straightforward send on the blockchain. It really appears to be a movement of funds within a user's own wallet. This next example is called a PayJoin or pay to endpoint. This again is the Samurai wallet with what they brand as a stowaway transaction. And in this case, the sender and receiver are again coordinating their activity with one another. And the sender is able to send the receiver a specific amount of funds, but that amount is not displayed anywhere. And it does appear to be the movement of funds for a regular payment in which either 0.0188 or 0148 is being paid to a recipient address, and the rest is coming back as change. So this violates the assumption that all the inputs are the same user, and so it is a CoinJoin, but it really just appears to be a regular spend of a different amount. This next example is an example of Boltzmann clustering resistance. As you can see, this sender controls all of the inputs on the left. And the receiver does simply receive money into an address. It requires no coordination with the receiver whatsoever. So this is technically not a CoinJoin, but it does look like one. All of the inputs appear to be CoinJoin denominated inputs. And this process hides a spending action within what appears to be a mixing transaction as well. And so not only is the receiver able to look at this and determine that CoinJoin may have been used, creating plausible deniability on the sender's behalf, but to an outside observer, it can actually look like this is a mixing transaction. You'll notice that the outputs on the right match. So there's two outputs of 0.015 and a couple of outputs of approximately 0.005. And so this could appear to be a simple mixing transaction in which funds aren't being spent to a third-party observer and instead are simply being mixed in different ways in order to between a set of users. And so again, this does confer a level of privacy and complexity to the blockchain analytics that otherwise wouldn't be there. Again, Dash does not support this type of transaction. Next up is transaction hopping. This is actually relatively straightforward, but intended to thwart blockchain analytics software that may not be sufficiently sophisticated to analyze transactions further back into the blockchain. And so in this case, the sender intends to send funds from the address in the upper left. They intend to send 0.02 Bitcoin to the address in the lower right in purple. And so what this transaction does is it starts with the 0.02 BTC in the lower right and adds on a transaction fee for each of the hops for which it intends to do. And as a result, calculates that 0.02075 Bitcoin is needed in order to conduct this transaction and pay all of the necessary fees. And you can see that amount in the upper right in the orange. Now, what this user does is first send that amount into the orange address. They then send the funds from the orange address to the yellow address. They then send in the next transaction from the yellow address to the green address, from the green address to the blue address, and finally from the blue address to the purple address. Now they control all of these addresses except for the recipient, obviously. So they control the orange, yellow, green, and blue address, and simply move the funds around within their own wallet to create artificial transactions or unnecessary transactions in order to separate or create separation in the blockchain between their originating address and the destination. Now you can see this is relatively unsophisticated, but nonetheless can help to thwart the efforts of automated chain analysis software to determine whether a threat exists. And so this can be implemented a couple different ways. It can do all of these transactions at once or can space them out over a specified period of time and create as many hops as the user deems necessary to overcome the programming or chain analytics software. And so that's really a sample of the types of transactions that simply aren't supported on the Dash network. Again, this last example, Dash does not support automated transaction hopping in its software. And so all of this information, reference to all of the transactions themselves, can be found in these links within the presentation, which we'll also publish. And you can see for yourself the transactions and what information is then recorded on the blockchain. But again, there are quite a number of features that Dash simply does not support. We also outline in the paper a number, or in our response, a number of technologies that are not associated with CoinJoin that are also privacy enhancing, including some of the coming features with Taproot that's launching on Bitcoin this year as well. And so we at Dash Core Group are frankly at a loss as to why the FinCEN and Department of Justice are concerned with Dash specifically. Dash's implementation of CoinJoin is relatively straightforward compared to what else is available that the government evidently does not have an issue with. And we're really, frankly, concerned because the project is damaged by the publication of this information by FinCEN and Department of Justice. We are wrongfully being targeted based on seemingly outdated information on what a privacy coin is or should be in today's landscape. And that harm may be irreparable to the project if not remedied. And so we ask that the government assess this information and our arguments for why Dash should not be named as an anonymity enhanced cryptocurrency, and we believe that Dash should be stricken from future references in relation to anonymity enhanced cryptocurrencies to the extent that the government even deems the concept of AECs a valid concept to include in its policy making. We personally do not believe that it adds value given the complexity and the direction of the industry as a whole. Privacy is something that only continues to grow in importance to users and continues to be enhanced by developers. And it is a moving target that really doesn't have much of an effect at this point, given the level of sophistication on the ability of risk scoring and risk evaluation and risk management on behalf of the exchanges. And so, in conclusion, we strongly object. We would like Dash stricken from the list of anonymity enhanced cryptocurrencies, and we encourage the government to invest more heavily in understanding the privacy technology that exists in the marketplace. Thank you.